When armies advance on Babylon, we must vanquish them before they reach Babylon.
I was a governor. We had to study the code of Hammurabi.
They got to look at these rules. That just inspired me more to learn about laws.
My person was named Gungi. He wanted to be the best grain merchant in the land. I had to have clay and write the trades and record them.
We're going to be designing a windmill, and we have to make it spin by the force of wind.
Our axle wouldn't spin because the cup was too tight, so we had to loosen the axle by cutting 2 cups. And then we put the axle in and the axle spin because the cup wasn't loose, but the base was still strong enough to hold the axle.
Today we're about to build a shadoof which can transport water from one place to another.
Right now, we're saving the Earth from Sedna, which is a mini planet. It is coming towards Earth, as you can see, and eventually it'll crash into Earth and destroy all of humanity. So we're trying to stop it. I tried to make both of them the mass of one Earth, and Sedna took over Earth. So try one thing. Yeah, I know, that's what I'm trying.
Go, hit it.
I'm guessing that something that has more mass has more gravity, so this was still moving towards it, but this was moving faster.
Continents were separated and you have to connect them together. Then you have a moving device where you can spin the continent around to help it connect. And then you also have a sonar, which helps you find where a continent connects. Then these will help you find fossils, which fossils can connect to other continents.
Where is the other one? I did it. Exactly.
The point of the game is to use what's called the leap, which is a motion sensor, to make different types of tectonic plates. For this one, you need to pull the tectonic plates apart in the game, and that's what makes the Rift Valley.
The game taught me that convergent means to go together, and since volcanoes rise, the magma rises too, and the game gave me a visual like the magma rises up, and that's when it erupts. In this game, we get to use our hands, so it doesn't only use our mind, but it also uses physical ways so we can remember.
there's a 1 and a negative 1, like there is the light version of the creature and dark version of the creature. They both cancel each other out, and it started looking like algebra.
There are negative numbers, like there's like variables, negative numbers, and positive numbers. Yes! I did it!
At every level you said, oh, how do I do this? And then you do it, and you don't know how you did it, and you have to go back and see, oh, that's what I did.
Dragon Box like really taught me like how to do algebra, and it's like really fun in my opinion. Every week I ask for like 10 algebra questions. I love algebra.
Right now we're trying to make a perfect amount of H2O and CO2 and light to make oxygen and sugar so our plants can survive through winter.
I'm researching about sunflowers, on how they grow and what they look like. This is capturing all the sunlight and the H2O.
For the plant to grow, it needs sunlight, starch, and H2O, and it's using that starch, H2O, and sunlight to create another root. Roots of the plant gather the water from the soil to gather enough pollen.
It needs to gather enough pollen to make fruit.
And fruit contains the seeds that create a new plant.
No, don't make it too.
This needs to go a little bit higher and then go. Oh, that's a good idea.
Oh, man. Kinetic energy is the energy you're using. It's like what's going. And once you drop, you get rid of the potential energy, and then it becomes dissipated energy, but you're also making kinetic energy.
Cross this last corkscrew down, up a little bit, and then it's gonna fall.
Yeah, we actually use like tubes and pipes, and we put a marble in, and we actually made it like a little roller coaster.
This is potential. That's kinetic, and then it's gonna regain potential. All right, let's go. Let's go.
Right now, we're dealing with feet per second. It's distance over time.
Oh, we just calculated the speed per feet of a roller coaster, and it's 4.4 seconds. No, wait, 4.4 feet per second.
So what we're doing is we're trying to get this ball to the balloon. We're trying different techniques to get it there.
There's so many ways that each level can be done. I learned a lot about creation and pins and pivots and levers.
So far, I am making my pterosaur game. So that's my dinosaur. So if we were to collide with the wall, it would stop. That's what I just learned.
So I wanted to make my grasshopper jump naturally, so I want him to know how far and how high you're supposed to jump. For me to know how the grasshopper should jump, I have to know the quadratic formula. The first point of the parabola is the starting point. The second x is the second point of the parabola, meaning which is the vertex, and the third point of the parabola is where it lands. So by using the quadratic formula, I can determine the vertex and which angle it's jumping to.
We are a boatload of PE right now.
At Dream Lab at GameDesk, trying to create lessons that involve play to really engage students and get them motivated to learn.
We created a game around friction, which basically has the kids taking a block that slides down a slope and then across 5 platforms. And the kids get a chance to actually change the materials that those platforms are made of so that they can experience different types of friction.
I thought it was really informative. What you'd hope for in a classroom, anywhere.
I thought it was one of the best workshops I went to. I think because I had a chance to play, and I love to play.